Welcome everybody to Tunes Day Night. I'm your host, MC Toon. Tonight we have a debate on relativity with Nero Defogger. Nero is not a flat earther, so don't be tempted into thinking that. Nero is watches my videos and apparently enjoys them enough, but has things to say about relativity. So welcome, Nero.
Hi.
You could talk a little louder. Why don't you
I'm
introduce yourself a little bit so people know who you are a little bit at least.
yeah, I'm a little shy actually. Set the volume so they can hear me all right because maybe I'm low. I don't know.
Yep, I did. Volume looks good. All right, so the Nero contacted me a while ago asking to debate relativity. He said, how come I'll debate with Sam about relativity, but not him? I said, all right, let's do it. So anyway, let's kick it off, Nero. Go ahead with whatever you've got to say.
Yeah. I'll introduce myself a little.
Okay.
They can call me Nero. Just Nero. It's all right.
Yep.
I'm from Spain. My main language is Spanish, but I know English. Hopefully, good enough. I don't actually like Genshin Impact, the game that Paimon is from. Um, it's just an avatar I use. What else? What else? Yeah, as you said, I'm not a flat earther. I just have problems with relativity. And finally, my background. I didn't study physics, like an official, like from official school or university. I did software development. I have an official degree in software development.
Software development.
But I did study physics and engineering and many things on my own. Yeah.
All right.
I think that's most of it.
Sounds good. So what do you have? What's your beef with relativity?
Like my main issue. Or, basically from like 2020, the year 2020 more or less, I started researching quite a lot about physics, and I didn't like many things that were especially related to relativity. When the things were related to relativity, it didn't seem to make much sense. And then I like looked at it further and further, trying to like see the things that I didn't quite like. It didn't seem alright. And after like 3 years, the day 6th of November, the year like 2 weeks ago, it was idea of my father to go to the library, and I went to the library and I saw one book, and that was like the last clue I needed. After seeing it in the what I read in the 3 books that I read in the library, then I went to search it also on the internet on many places. I even saw it on your website. That basically, it's like thought that the Michelson-Morley experiment basically proves the constant of the speed of light. Like after like before that moment, I always thought that the Michelson-Morley experiment was only about the either, proving or disproving the either.
The Ether?
But what I saw is that they use it as a reason to believe that the speed of light is constant always. And that's what I think like is the main confusion. I think they use the Michelson Morley to try to prove something about light that I don't think it does.
Okay.
I saw some of in your website.
Okay, like what specifically on my website?
I'm gonna search it.
Oh.
Um,
I've got what related to Michelson Morley, I've got a page dedicated to
yeah,
Michelson
let me
Morley
find it.
experiments that have been redone.
Yeah. You're showing also your website. Yeah, there.
Yep.
So yeah, basically, what I saw on the three books, all three books in the library agreed. And when I go when searching on the internet on many places like your website and so forth, like all of them seem to agree. The Michelson Morley experiment proved one that the either doesn't exist, and secondly that the speed of light is constant. And that's the thing that I don't see. Like, why that second conclusion? I don't see any
That the
reason for
speed of
that
light is
second
constant?
conclusion. I even I thought about going to the to go search this, and because I told my father that I I couldn't even think of an experiment that could be done in that time.
To measure the speed of light?
That could no to measure the difference of the speed of light
To see
with
if it changes.
with conservation of momentum,
Wait, the speed of light with
which is like
conservation of momentum?
yes,
How
because
how are they related?
the speed of light is 3 e8, like 3 times 10 to the 8
Yeah.
meters per second. But that's like the magnitude. Then, like, there's the precision, you know? Like, it could be off like by 1 meter per second, more or less.
Okay.
The magnitude will be the same, but there's precision. Then, they found the speed, but first, it didn't have a lot of precision. And with time, with more measurements, it slowly had more and more precision. But I couldn't think of anything, any experiment that could be done in that specific time that could measure to such precision that you could measure the difference speed with conservation of momentum
In
because
what particular
of
time
small
frame?
things.
Like what time frame? What era? The 1800s, the early
Uh,
1900s?
when the Michelson Morley experiment, yeah,
Okay, so yeah,
in
Michelson measured the speed of light in 1880. The experiment he did with Morley, he had done some initial stuff in 81, I think, but they published in 1887. But yeah, Michelson measured with a rotating mirror in 1880. I think he got the Nobel Prize for that. If I don't, if I remember correct,
Nobel Prize for what?
for measuring the speed of light.
Yeah, maybe.
Yeah.
As I said, one thing is the overall speed, and another thing is the precision. And I do believe that they got some precision, but it's hard to get to a certain point of precision. And especially, the best way to get a lot of precision is by getting a measurement from a lot of distance. If you, for example, had a cable that went um, around the globe, because I'm not a flat earther, if you had a cable that went around the globe, you would have a lot of distance. And then the time it would take the light, it would be a lot of time. So you could get a lot of precision. But that speed is like with all the cable is static, unquote. Like it's not moving. So maybe with that you could get enough precision to measure to 1 meter per second, like the exact speed with a lot of precision, but there wouldn't be movement. And if you have a movement, maybe because you're using a plane, in that time some planes probably were around.
Like an
You have some
airplane?
planes, yeah, but then they wouldn't have a lot of distance. So you wouldn't have enough precision to measure the
So
difference in speed
so
because
did
it would
you
be very low and you wouldn't have a lot of precision there.
did
I
you
couldn't
read
come
how
up
they
with
did
an
you read
experiment.
how they did measure the speed of light in these times that you're concerned about their precision?
What, sorry?
Do you read about the procedures that they used?
A little bit, yeah.
Um, did you find anything in particular wrong with the methodology?
No, but I haven't seen to this day a single experiment that could be done in that time with that technology that could prove basically the thing that Einstein assumes in the special relativity paper, the light being constant. The,
Mm-hmm.
the
Well,
yeah, because if you had a lot of distance, then it is static, so you
but
can't
to be
measure
clear,
a change
Nero,
in.
yeah, just a second. To be clear, the speed of light was constant before. It was known to be constant before Einstein, um, at least in our reference frame. So it wasn't. And so if you look at the history, and I have some of the numbers up on the screen right now. These were before 1905. We've got Fizeau, Foucault,
Yeah,
Cornu, Michelson, Newcomb, all before 1905. So it wasn't. It
yeah,
wasn't that Einstein proposed that the speed of light was a certain amount. It was that the speed of light was constant in all reference frames. That's what he introduced.
exactly. Yeah, exactly.
But the speed of
And
light was derived independently of the measurement too. You know that.
what?
The speed of light was an outcome of Maxwell's equations, and that's related to some constants that were measured.
Like,
So, it there were multiple lines of evidence for the speed of light from different sources.
but are you talking about the amount, the magnitude of the speed of light, of it
Yes.
being
Yeah.
3 times 10 to the 8 meters per second?
Yeah.
Or are you talking about it being absolute constant no matter what in all reference frames?
Within our reference frame, Maxwell's equations output a certain number.
Exactly. Yeah, and I agree with that. That it is constant, like it's always three
Okay.
three
So
times
so
10
what's
to
your
the.
what's your complaint then about measuring the precision of the measurement, right?
Because you need a lot of precision and in a specific kind of experiment to disprove that the light is always constant in all reference frames with the like the assumption that Einstein does. And that's what I think that people assume the Michelson-Morley experiment does. But I don't think it does because
That
the apparatus was static. It was static. There wasn't movement. Of
what was
course, the,
static?
the speed was.
Well, I
What,
don't I
what
don't I'm
I can.
I don't know if you're not quite explaining what you're thinking about here for the Michelson Morley.
Um, it, people like most modern science and most sources and the books I read and all of them seem to agree that it's the Michelson-Morley experiment, the one that proves, or like one of the ones that prove it the most, that proves that the speed of light is always constant in all reference frames.
Yeah.
And I disagree with that.
Okay.
I don't think the Michelson-Morley experiment can prove that because it it wasn't even moving. Like one thing is the speed of light, but
What do you mean it wasn't
there's
moving? It was moving with the Earth in orbit around the sun.
yeah, but not the like there weren't two different speeds, like one part of the apparatus moving and the other one moving in a different way. The whole thing was static. The only movement was of the Earth and all of that because of the Aether. But that's the thing. It is not it's not related to the Aether in any way. All of this, like, I'm not talking about the Aether, which, all right, I do think the Michelson-Morley experiment disproves the Aether.
You don't think
But
it disproves?
I do think it disproves the Aether.
Okay.
I do think that, yeah, but
Okay.
that doesn't mean,
So Michelson-Morley disproves the ether, but you still
yeah,
don't accept special relativity. So why
exactly.
did the Michelson-Morley experiment output a null result?
No result on the Aether.
Yeah.
You're saying the null result on the Aether, on the
No.
predicted Aether,
Yeah. So
because it doesn't exist. Like, I agree.
yeah,
Like, it
yeah.
seems that it
So
doesn't agree
that's what
because
they
of
were
that
testing
experiment.
for. They were testing for the effects of the ether as the Earth moved through
Yeah,
it. And they
yeah.
determined that there was no ether in the end. I mean, Michelson never gave it up, but other people looked at it and said, yeah, there's no ether. So,
Yeah.
but that wasn't, Michelson-Morley wasn't measuring the speed of light. It wasn't clocking at one direction and saying, okay, we got this number this direction, and then clocking at the other direction saying we got the same number. It was actually just comparing two beams and seeing if there was a difference in the two beams. It did not put a speed.
Yeah, exactly.
Yeah.
Exactly. Actually, that even proves more that it can't prove that second conclusion that then Einstein used for the speed of
Yeah,
light.
yeah. So then Einstein.
It's just an experiment that only does, like, proving or disproving the Aether. It's the only thing. But they claim they prove another very separate thing.
What?
I didn't even think that they thought of the Michelson-Morley experiment this way until November 6th, 2 weeks ago, because I was sure, like, yeah, Michelson-Morley experiment is just about the Aether. What does this have to do with anything? I was confused, but then I realized they thought that it was the reason that proved the Einstein claim of light being constant in all reference frames, which is a separate thing.
Okay.
Understand what I
No,
say?
no. I'm not understanding where you're coming from, Nero. It,
Right. Maybe I can try with
so
I,
why here's the thing I'm asking then. Why we know that the Earth is orbiting the sun, and we know that that's happening at a certain rate. Since 1887, we've become much more confident in these velocity of the solar system through the galaxy, and the galaxy through in relation to other stars in the universe. So we're moving at a high rate through space. Given that we are moving through a high rate, why does why is there a null result from Michelson-Morley?
I said many times, I do agree that the Aether probably does not exist
Yeah. Okay.
because of the Michelson-Morley experiment.
Yeah. Okay.
And as I said, I was confused until very recently of why they brought the Michelson-Morley experiment and all this Aether thing to the speed of light and it being constant and Einstein and relativity, because I didn't even see a connection. And it was until very recently because I found out that they think that the Michelson-Morley experiment proves two separate things. On one side, it disproves the Aether, and on the other hand, it proves that the speed of light is constant in all reference frames. But I disagree with that second conclusion.
Okay.
I don't think that experiment proves that second thing.
Okay. Do you think that the speed of light is different in different reference frames?
Yes.
Okay.
And that's what this was my main thing. But I have evidence, kinda. Like, I
Okay.
have some scientific papers from people with PhDs that made experiments with satellites.
All
Now,
right.
modern with modern technology, with satellites, that seem to prove that there is different speeds of light.
Right on top. I got the appeal to authority card right on top. They have PhDs. I don't care.
Dude, I'm not saying it like.
I don't care
I'm
if
not
they have
saying
PhDs.
it like absolute. I even said kinda before.
Okay. All right.
Because I'm not saying like, all right, they have PhD. It's 100% true. No, but like I'm saying, I have some evidence, some things to maybe worth looking at. That it seems with that with modern technology, they were able to actually measure different speed of light.
All right.
Because now we have far better technology.
Yeah. Is this by a guy in St. Cloud, Minnesota?
Then I can send you the PDF.
You can share screen. I'll if you want. Otherwise, I can pull it up if you send it to me.
Yeah, let me.
Indie Tiger's sci-fi review says, I'm not a fan of Maxwell Light. Maxwell Dark Roast is better. That's good coffee. Sounds good, Indie Tiger sci-fi review. I prefer a light roast myself. Dark roast gets a little burnt flavor. I don't like that as much. I like the earthiness of the light roast.
Yes.
Okay.
I can also show them myself or whatever.
If you want, I can do it either way.
Yeah.
There's big implications if the speed of light is not the same.
Yeah. Exactly. If that assumption, that initial assumption
things like
is wrong,
the relationship
then
between the electron and the proton have problems. All sorts of things are then all tossed around, and Nobel prizes will be given to whoever confirms it.
No, I don't think so. Many people say that disproving Einstein would grant Nobel prizes, but I don't think so.
Well, I think so. And my vote is equal to your vote. So so there we go. It's 1-1. Haha.
But I'm not sure, but I don't think so because it's not like bringing something new to science, but just like.
Oh, it would be something new. It would be what Thomas Kuhn calls a scientific revolution.
I'm just going back. Like I'm just claiming that Newtonian conservation of momentum kind of physics still like are the thing.
Still other thing.
I'm not claiming.
So
like I'm just saying, like if I was back in time to that time, I would just say, why did Einstein publish this paper? I don't. Why does it assume? Why does he assume speed of light is constant? I don't see it. And that's it. I wouldn't be doing anything special.
That was the hypothesis he started with, and then he worked through the consequences of that.
Yeah.
Yeah.
He assumed it. Yeah. Just like that, and then supposedly there were experiments that proved it.
Yeah, there were several experiments that were done that confirm.
Like the famous, because I'm told of them every single time, the mercury perihelium and the.
Well, that's general relativity.
And the sun gravitational lensing.
Yeah, that's general relativity. That's a bit of a different topic than special relativity.
But they're the relativities, which are supposedly being backed up by those experiments.
They are related. Charlie Welch says, I listened to too much Arwen. I speak elf. All right, are you gonna pull it up, or do you want me to pull up?
I don't know.
You don't know?
Maybe I can show it myself. Wait.
We could do rock paper scissors lizard Spock.
Is that right? I do it.
Which reminds me, I've got a. You see this here? Oh, hold on.
Wait. Why is there two?
Right there. Look at that. I've got my Star Trek.
I'll try.
My Star Trek emblem there. Thanks to Neil. Neil sent it. I'll show you in a minute what else Neil sent. All right. Are you all I just see is the blank screen there so far.
Oh, because what? Oh,
Right there.
because of this. Right. Can you see?
I just see I think it's pink. Is it pink?
Pink? No.
It looks pink to me. Oh, nope. Now it's gone. Frank Burns says Toon is drunk already. Hi, Frank. Hey, look at this right here, Frank. Look at that. Just for you, buddy. Thanks for that.
Yeah. Can you see?
All right. Demonic Leprechaun says yes, it's pink. There it is. Back to pink. Let's see.
Can you see it?
What songs did she sing? Let's get this party started. Was one of her songs. Right? Can you name any other Pink songs? I only like one of her albums, really. Yep. I still just see Pink. A Randomly Epic, yes, that was also Black Eyed Peas, but a different version, a different song.
Here on Discord, I say it like if it's sharing screen.
Yeah.
But yeah, on your stream, I don't see it, so
all I see is
I don't
pink.
know what's going on.
Yeah. All right, let's get this party started. We're having a little technical
Why isn't
difficulty.
it showing up?
Get this party started on a Saturday night. Everybody's waiting for me to arrive. Sending out the message to all of my friends. We'll be looking flashy in my Mercedes-Benz.
We tested it earlier and you could see. Why is it now not working?
I don't know. YouTube says Pink also sang Funhouse, which was the anthem from our old apartment. Very nice.
Shared the entire screen.
Prosthetic Head says, what color Federation uniform do I wear? Transparent. No, you wouldn't want that. Oh,
wait.
All right.
I can see like the three things. Like I can see myself on the screen. Are you focusing on me and not focusing on the screen share?
I don't see. I don't know. I don't have any. I don't know if I have any options.
Click on me. Click on the pink.
Click on the pink. Oh, there it is. All right. There,
yeah.
I can watch your stream. There it is. All right.
Yeah. All right. Then
Let's get this party started. Pumping up the volume, breaking down to the beat.
Oh.
Cruising through the west side, we'll be checking the scene. Boulevard is freaking. As I'm coming up fast, I'll be burning rubber. No. You'll be kissing my. You're gonna have to finish that one on your own, people.
You can see, right?
Yes.
Yeah.
All right. GPS and the one-way speed of light.
Yeah.
Is that Ruyan Wang?
I think.
Who wrote that?
I think both papers are written by this guy. Which I think is from an island near Cuba, I think. Don't know. Again, with a PTSD.
In Iceland near Cuba.
Yeah, I think because here.
What version of the globe are you from? Are you from like an alternate version of the universe, like a parallel universe where Iceland and Cuba are near each other?
No. An island. I don't know.
Island. An island. Yes, yeah. We don't pronounce the S.
Here.
Okay. All right.
from Trinidad and Tobago, which is near Cuba,
Yes.
if I
Okay.
remember
I guess
correctly.
that's they're a Caribbean island, Trinidad and Tobago.
Yeah,
Okay.
these are the two, and I think Sifal CG gives.
Okay.
And in these papers, he also mentions other ones, like I, but like he mentions other paper from other scientists stuff. So well, I don't know how much research it has because it doesn't have like it's not popular.
It's
It's
not
not
popular.
talked about. Yeah, because I never hear of any of this. I
And,
found out very recently because
and
I
is that
researched it.
because you're well connected to the uh the streets, the
What?
relativity streets, the mean streets of relativity?
I don't know what that joke means.
Okay.
Um,
One way speed of light, and what's this one called?
this one, the one
GPS and the
light
one way speed
and
of light.
one
Okay.
way light speed that I was
All
saying.
right.
Basically, in these two papers and the papers that it mentions, they use GPS and satellites. Basically, as I told you, because that's modern technology, and you can do much better this because you can do very uh, like from a lot of distance and a lot of speed. If you, for example, have two satellites orbiting, but in in the opposite direction, they are going like I don't know if, for example, the speed at low Earth orbit is um like seven kilometers per second, and if they are going in opposite ways, they have a total of 14 kilometers per second. They have a lot of speed, and they can be somewhat far if they are, for example, in the extremes of the geostationary orbit. They can be quite far and going at quite a lot of speed. And we also have more precision with the atomic clocks. So I believe with all of that, it's possible to measure
Okay. So did you
better.
read through the whole thing and then
Yeah,
understand what
I
he's
read.
talking about in there?
Yeah, I read most of it, and there were some. For example, Marmet and Kelly both concluded that these observed travel times differences, the synchronized clock measured in each direction, um, occur because light travels at speed c minus b, the speed of the emitting thing, eastward, and c plus b westward, relative to the surface, where b is the speed of rotation of Earth, or like if they are following the Earth rotation or whatever, like the conservation of momentum applies to light. That's the thing.
So, all right.
This
Which one
research
is?
by
Hold on.
Marmer and
Is
Kelly
this?
was precursor to the series papers by this author. There are
Which one
other
is this that
scientists
you're
that
reading? Is
did
this?
other experiments.
Um. All right,
And
wait.
using atomic clocks, probably he says.
Is this the one titled GPS and the one way speed of light?
Um, yeah,
All right. I'll give it
um,
people. You can get the
I had
DOI. Here's the
some.
DOI
Let
link.
me search. I had some quotes that I quote mined.
That you quote mined. Awesome.
Yeah,
That's the way to do science, isn't
yeah.
it? Okay,
Where
so
is it?
is this an actual experiment or is this a write up on a proposal to do an experiment?
No, they did experiments.
Michael Simone using GPS
Well,
clocks.
or so they claim.
So they claim.
Like they could be lying, but
Well, yeah. When reading a paper, you generally accept that they did what they said they did, um, and then the important part of science is that something be repeated. Repeatability is important, so you'd want somebody else to do it. Right? So, right? You're doing okay. You're doing Inception
Um,
there.
In what's this one? This one is this one. And yeah, we read through the first one.
Who's we?
No, wait, but wait, you and me. But it's
No,
in
we
this
didn't.
paper.
We didn't read through anything together.
Well, I read through it while you were listening.
While I was listening to you talk.
Yeah.
So you read
It
it
was on
while
screen.
you were talking, while I was listening.
I don't know.
Okay,
I got lost.
I mean, I'm kind of just breezing through this. I don't know if they actually did anything.
But
I don't.
in theory, they did. I even saw when I read it, it had some measurements of like what amount of nanoseconds it took.
Okay.
If I can see it, let me see. Where is it? I won't find it now. It was like here.
Oh, just a second. We've got a visitor. We've got.
You can see it, right?
Oh no, not right now, because I've got a turtle wearing a turtle costume. Look at that. See that? You can't even tell that it's a cat wearing a turtle costume. It just looks like a turtle, right?
But I don't see.
Meow. What do you think, kitty? All right. He's
Oh,
not
wait.
as upset
It's
as he
not.
usually is.
Oh, there. I had it like it was.
Okay,
Yeah, I
well,
can see.
hold on, Nero. We've been interrupted by cats, and cats always win. This is
It's
a
all right.
raccoon wearing a raccoon costume.
Cats can always interrupt.
Yes. Look at that. Look at that cute little tail there. She's much more understanding. Hey, kitty. All right. Thank you.
Bye.
Bye. All right, Nero. Okay, go ahead. You can. We've got Inception going again. Okay. Which paper is this and what page?
See?
So I can look at it.
Yeah. And the paper, this one. Range measurement equation, GPS.
One way. All right.
And here on the first page, it says, let's see, from here. Based on GPS timing, Marmet, year 2000, observed that the light signal takes over 40 nanoseconds longer than the average time. The average time equals the distance divided by c, traveling eastward from San Francisco to New York, while the signal takes about 14 nanoseconds less than the average time traveling westward from New York to San Francisco. Early 2005 also noted that time measurements using GPS showed that the light takes 2000 nanoseconds longer to circumnavigate the entire globe and 2000 nanoseconds in the other direction. Like this. And these are, as I said, other people. Armed 2000. I don't know if it's like maybe they are there here. Yeah, it seems. Armed 2000 GPS and the constant velocity of light. We could probably see this, but I haven't read all of this. But you know.
All right. Well, this one also, I'm not sure if this actually is an experiment or if it's just talk. So let me see here. Based on GPS
They say
timing,
they measure nanoseconds. What would that mean? They could be lying, but
no, they said based on GPS timing, Marmot in 2002 observed that a light signal takes about 14 nanoseconds longer. So they're analyzing a different experiment. Where average time equals distance divided by c. Traveling eastward from San Francisco to New York, while a signal takes about 14 nanoseconds less than the average time traveling westward from New York to San Francisco. Kelly, 2005. Also noted that time measurements using GPS show that a light signal takes 207.4 nanoseconds longer to circumnavigate the Earth eastward at the equator than the average time, while a light signal takes 207.4, the exact same amount, nanoseconds less in the westward direction around the same path. The identical number to 4 digits of precision. So when it's not an absolute thing, but when you see the exact same number in actual real world measurements, sometimes it's something to pay a little more attention to, because it's uncommon to have exact measurements be the same. It happens, but it's not common.
But it can happen.
It can.
Are you
Yes.
seriously gonna focus on such a tiny detail?
It's something that makes me wonder a little. But I mean, to do it, we'd want to look at Kelly's paper. You know that's what you would have done next in your iteration. Is jump to Kelly's paper from 2005. Did you look at that one?
No.
You should have. I mean, that was the actual.
I mean, not yet.
It's called Kelly A. 2005 Challenging Modern Physics, Brown Walker Press, Florida.
We can read it now.
Yeah. Let's see. I got the DOI for this one. That's the one-way light speed determination is the one I just posted the DOI for. So there you go. Okay, we got more Inception there going. So yeah, I'm not going to read it now.
Yeah, that's the thing. Like, we could be reading papers and papers, but like I got two.
And that's why when
references more.
Yeah, when I was chatting with you about this, I said, "Hey, we should talk about stuff." So if you watched the debate that I had with Alan, Space Audits guy on Jaren's channel,
I think I saw something.
We exchanged citations beforehand, because a real if you're really doing a debate, which no flat earther has ever really participated in a debate, they don't have evidence for their side. All they have is denial of the globe, and a misunderstanding of the globe. But in a real debate, you exchange these things ahead of time so that you can have a conversation about it. I can't look this up and understand it on the fly. So I think it would have been good if we had been able to say, well, yeah, let's here's the structure, here's our topics, let's look at the details, and here are my citations, and I would have sent you mine. But we didn't do that. So now we leave the audience unsatisfied, Nero.
Yeah, but
they don't get to see a flat earther get crushed, and they don't get to see you and me have a conversation about this topic in any useful way.
But these are for, like, as I said, proofs that maybe now with better technology we can measure the difference in the speed of light. But I don't believe that it was proven that there was, like, the light speed was constant in all reference frames in 1987 with the Michelson Morley. I think that's completely flawed, and that Einstein using that with special relativity and all of that, I think all of that is it's not true. It's not right.
Just you don't like it. Yeah, 1887.
Because
he didn't mean 1987. He meant 1887. Okay.
Because as I said, it disproves the either, not the speed of light thing, because it didn't even move. I don't know what was the precision of the experiment, but the precision of the, well, you said it wasn't even measured. It's just not relevant.
That wasn't its intention to measure the output of magnitude.
Yeah. But even if it did, it And even if it had precision, like even if it did measure the speed of light, and even if it had precision to 1 meter per second,
Mm-hmm.
and it gave the 3 times 10 to the 8 meters per second, the thing wasn't moving. You didn't expect it being 301,000 kilometers per second because there wasn't any movement in the apparatus. Like as I said, the GPS, the satellites, they have speeds with each other, or if they are pointing to the surface of Earth, they have a different speed. That's the thing. That's the difference in speed. That's the conservation of momentum. Like Newton and like all the physics always said, if you're measuring things that are going at the same speed, then of course you don't have a different speed because it's the same frame of reference. That's the thing. I guess that's the thing. The Michelson-Morley was done in just one reference frame, not multiple reference frames. So the speed of light is not constant in all of reference frames because that was only one reference frame. And I don't even know why they concluded
this
that.
paper says.
What?
I don't know what this paper says. So
The two papers I sent.
yeah.
But they are irrelevant right now because we are not talking about them.
Okay. So I mean, so then it sounds to me like it's just down to you just not liking it. You're like you just don't think
Not liking, no. The experiment wasn't done to measure that, and it physically, technologically, it can't measure that thing. It's like me dropping a water bottle and say I measured the mass of Jupiter. Because I just say I just measured that. And it is whatever number I say by dropping a water bottle.
But
like the
that,
experiment has to be able to measure that. And how do they claim that it can measure?
But that experiment wasn't designed to measure that. That would not be where you would look to see whether or not the precise measurement of the speed of light.
It's not only that it wasn't designed, it couldn't.
Go somewhere else. Yeah, it doesn't matter.
It couldn't measure it.
It also didn't measure the mass of an average hamster. It doesn't matter. That wasn't its point.
Yeah. Yeah, no, but then they are claiming that it does like measure the mass of hamster. That's what Einstein is claiming in its special relativity paper. It literally says
Einstein,
if I search
Einstein in 1905 did not mention Michelson-Morley. There has been a lot of debate on whether or not Einstein even considered Michelson-Morley in his paper. I'm of the opinion that he did. He was aware of it.
Yeah. Yeah, he doesn't directly mention it, but he mentions it being like somewhat proven or like something like that. And from what I seen, as I said, the initial thing I saw was those three books in the library, and then I saw the things you had in the website, and I saw Wikipedia maybe, and some other places.
What were the 3 books?
They all claimed.
What were the books?
I don't know the name.
I'm gonna write them down.
They were like, I don't even know, like, because they are here in Spain, so I don't know. And they have like Spanish title.
Oh.
They were, like just physics books. It has like all of physics, modern and classic physics and stuff. And it was a big book and had like almost everything about physics. And at some point, it talked about the measurement of the speed of light and how from measuring Michelson-Morley and one of those measurements, how it like proved Einstein relativity.
Okay. Now are you aware that there are multiple lines of evidence for relativity?
Of what?
Like what?
Relativity.
Yeah, time dilation is another prediction of
I don't think
relativity.
I don't think it was ever measured.
You don't think what was ever measured?
Time dilation.
Why not?
Because as I said, like I've heard of the Mercury perihelion and the sun gravitational lensing. Like I've heard them
not
mention it, but I've never seen like anything that really convinces. I haven't seen the maths, the specifics of the experiments, and things that were really convincing. Just claims, but
but
and I researched it a lot, especially the Mercury one. I researched that one a lot.
Mercury is not time dilation.
No, the thing they claim about the perihelion of Mercury and the predictions of Newton and general relativity. That stuff.
Jeez.
Libras. For us talking in Spanish.
You're talking in Spanish.
The people in chat, some are talking Spanish.
Okay, I got it. Yeah,
Says que libras.
I'm.
Que me los títulos.
Hey, I'm an American. I only speak American, so
Yeah.
don't get out there and talking Castellano.
Yeah.
Do you say nosotros or vosotros?
In like what? It depends.
Yeah, when you say both.
Us is nosotros and yo is vosotros.
What about which one's we?
And nosotros.
Which we all know in French means yes.
What?
Yeah. We
means, yeah, we.
Yeah, we means yes in French.
Yeah.
Okay. I got it up here. Let's see. So you don't think that they measured the time dilation?
Do you want to talk about the
what
time dilation?
Well, yeah, you said you didn't think that they measured it. So I'll show you. Let's see. So Carol Alley, that's the guy's name, Carol Alley. Let me get to the correct page. Okay. So they sent up some clocks in an airplane. They flew it around in some circles for a while or over Chesapeake Bay. They flew it at 3 different elevations. The reason why they flew it at different elevations was so that first they did it at low elevation so they could burn off some fuel. Then they moved up to a mid elevation, burned off more fuel, went up to high elevation, and then finished. So this is talking about the specifics. This is from Carol Alley in 1979. Let me get here. This is the graph. So right here on the left side, you can see this. This is the elevation on the left side there, and you can see it there. There are 3 different heights. You see that? And then this is a little hard to see. I'm gonna see if I can zoom in on the graph here, because all right, so this one here shows the elevation that they were flying at in those different. But this is
what's the unit?
This is this is delta t over t. So this is actually the change in time. This is showing how much the time changed. Then this one here, this bottom part, you can see that the gravitational potential effect. This one has a slightly different 3 different angles. It's a little hard to see. I think you can probably see it at home. But this
like
is,
what like what are the units of each dimension of the graph?
on the left side, it's delta t in nanoseconds.
Delta t. So the change in
the
effect of the time dilation.
Yeah, this is the clock drift related to the one on the ground.
Yeah, and the x-axis.
The x-axis is time. It's the number of hours there.
Time.
Yep. So the plane took off.
That's just time and change in time. Couldn't those clocks be like just drifting naturally? Like that graph is extremely
Yeah, it's showing a drift. Yep. So the one on the ground versus
No,
the
but
one
like
on
it's
the air.
consistent.
Drifting.
Like every certain amount of time, a certain amount of drift. It's like very consistent. Like if couldn't it be like just because like atomic clocks are very precise, they don't drift as much. But
Yeah,
other clocks that aren't as
yeah,
precise, they just drift on their own.
These are atomic clocks. And so now this is the key one here. This chart. Very
They are
visual.
atomic clocks.
Yeah, these
The
are
ones
atomic
you
clocks.
said.
So here we have again the drift between the clocks. So you see at the bottom there we've got 0. So the clock drift between the two, that there's that little fluctuation. You can see that line isn't perfectly straight there. And then at 20, somewhere around 25 hours, that graph takes a turn and heads up to right there. It's right just below 50 nanoseconds while
And what
the
was
clock was in the air.
What was the path the plane took?
The path that the plane took was in circles over Chesapeake Bay. I'll show you that. Chesapeake Bay is on the east coast of the United States. There you go. There's the graph of the dashed line is the route they took. So they just flew in a oval type pattern.
Where? I don't recognize the map.
It's Chesapeake Bay. Are you super familiar with Chesapeake Bay? I'm not. So
Chesapeake? No, I'm not.
yeah. So I mean, you probably wouldn't expect to be familiar with Chesapeake Bay. Yeah, you might be more familiar with something in Spain than something in America, right? So all right, let's go back to this one. So this graph that I was showing, this one shows the drift between the two clocks. You can see when it was in the first part from 0 to 25 hours about, the drift is right around 0 nanoseconds.
Yeah, but here it would be important to know what's the exact path that it does.
What's what?
Which the path that the plane does, so that it supposedly creates that effect of time dilation.
The path? Does the path matter?
Yes, of the plane.
It was doing circles though. So all of its eastward motion was
where it went, at which speed, which
motion.
altitude, exactly what, how, like what was it doing that created that drift.
Yep, it's in this paper. Yeah, but you see the consistent drift there.
But,
so that's while the plane was in flight. And then you see after the flight there, again.
That also seems to be a very small distance.
A small distance.
From what I'm saying in the.
Yeah, it was 20 hours of so they had 25 hours of baseline before the flight. Then they had the flight from about 25 to 40, about 15 hours of flight, and then another 20 hours of measurements that they did on the
and
clock.
They were just doing circles at the same altitude.
Well, 3 different altitudes. You see right here.
And this graph we are looking at?
This graph here shows where the different elevation changes happened. This isn't the elevation. This is the delta T. The drift in relation over time, and you can see that the amount of drift varies based on elevation. Now the elevation changes the gravitational potential, which is general relativity, not special relativity. So this is testing both at the same time, and the fact that they did it at different elevations is how they can differentiate between them.
But just by flying in circles in the same elevation,
yes,
in short distances with somewhat of the same kind of speed, and it just drifted.
Yeah,
that's the claim of relativity.
Yeah,
of time dilation.
Yeah,
just by moving in circles.
Yeah,
I've never heard of that.
Well, maybe you have a little more to do, a little more reading to do. It was at 3 different elevations.
I literally cannot read anything more. I've never heard that anywhere.
You literally could have read this.
Just now.
Yeah, not now. I know you couldn't now. So when you said, so this is just me saying, I understand that you're not going to have read this and you can't digest this and you can't respond to it right now.
Yes.
But when you said
real
you didn't believe, hold on.
I know that 3 different elevations, but like it's one of them is like constant elevation in this one. It's one.
All right. So when you said you did not believe that they measured time dilation, I'm showing you one of a couple different experiments where they did measure time dilation.
Send me the paper or whatever.
Yep.
I will take a look.
We'll get that to you.
I'll look at it.
All right. So the steps in this quantity are caused by the need for the aircraft to remain at 25,000 feet for 5 hours while burning off fuel before it climbed to 30,000 for another 5 hours before being light enough to climb to 35,000 feet for the final 5 hours. So there you go. So the lower curve is the plot of VA squared. VA.
And also, like, if like the relativity time dilation thingy, it claims, I believe, that like the time stays the same in your like reference frame. So in the plane itself, you shouldn't measure a drift thing. It would be once you come back and you like compare it with the ground.
They were logging it the whole time.
So what?
Yeah, they communicated from the ground to the plane while it was in flight. So they were able to constantly measure the drift.
But in each of them, there wouldn't be a drift. Neither of them could see a drift on their own. So the drift actually happened as they communicated with each other?
Yeah. That's what's cool about this particular one. The entire time, the clock on the ground and the clock in the air were comparing the drift with each other. So that's different than Haefel-Keating, where Haefel-Keating, they just flew it around the world one direction, flew the other direction, and they couldn't get a, minute by minute or hour by hour measurement. They just had a, from the beginning to the end measurement, a single one. So cool. They did it in 71, I think. This was in 77, I think. This was published in 79. If I'm remembering. It's published in 79, but I think they did this in 77. So, yeah, 15 hours in flight, constantly in contact with each other. And that's what these data points are. Here's another graph here. You can see the this graph here.
And the time dilation supposedly happens just because they are moving. Because it has a speed different to the one on the ground.
It's in an accelerated reference frame.
Accelerated?
Yeah.
Because of speed or because of acceleration?
Acceleration.
And what's the acceleration? Was the plane accelerating?
Have you flown in a plane before?
Yes, it accelerates sometimes, but not all the time.
Yeah.
Well, I guess if it was going in circles, I guess.
Yeah.
So if it was going straight, it wouldn't create a drift. Only when it turned because it accelerated.
No, that's not right either. It's
then what acceleration?
You got a little more reading to do, Nero.
No, suddenly you can answer my questions. And you supposedly read all of this. Or most.
I say, FE is free education. There's only so much free education to go around before you're gonna have to pay me tutoring fees. I mean, you're not a flatty, so that's different, but yeah.
I read a lot about relativity, both special and general relativity, but I hear like different claims, different kind of how it should work. Sometimes they say one thing, sometimes they say another thing, and like most of the times it doesn't even seem like very good. Like on the mercury perihelion thing, I searched a lot and I hardly found anything. Like most of them were just claiming that Einstein predicted it better. And after a lot of search, I found one that gave numbers. And those numbers weren't very good. Like the the like it seemed like it copied most of Newtonian physics, and even though it copied most of Newtonian, the like it didn't even got half of the margin of error. Like the error between Newtonian prediction and the observed amount, it seemed like it didn't account for even half of that missing amount, the Einstein
Okay.
uh, prediction. So like after searching a lot, and that one time I see numbers, they weren't very convincing. And the time I tried to read the paper that supposedly talked about the um, gravitational lensing around the sun. I talked about raining season in some town, but I joked about it on the Discord server.
It talked about raining.
That it literally talked about raining seasons on a somewhat town. I don't know. Yeah, it talks about that.
In Eddington's um,
Yeah, yeah.
experiment in 1919.
I don't know the time, but the
Yeah.
paper was about that. Yeah.
When Eddington went to, do you remember where he went?
Someone on the Discord server sent me a paper about it. I tried to read it, but I got tired after reading about raining season. But as I said, I'm not surprised because most of the things I see, they are like Einstein did it better.
So you didn't
He just did better.
get to the meat of it.
Yes, because it talked about raining season. You know, I waste a lot of my time researching this. Like I find a lot of, as I said, a lot of like I don't know websites or papers or whatever, and they only conclude that he did it better. He just did it better. Just trust me,
You
bro.
don't know. You didn't read it.
Einstein.
Um,
Yes, those are like Wikipedia, like scientific websites, and from YouTubers like you know, like science,
got too many books here. I'm
science
looking
guys on YouTube, and they just did, they say the Einstein's prediction just were much better. They just were. Just trust me, they were.
Well, I
Didn't
mean
even-
the
and I
actual
wasted
data.
a lot of time with that. So if I read raining seasons, I'm not gonna waste my time with that
Yeah. So
because I already wasted a lot of time.
don't care if you didn't read the paper. Then you don't have any opinion on the paper that matters. Eddington went to great length to explain what he did when he was in Principe. That's where it was, Principe, and the other team went to Sobral in Brazil, and Brazil has a rainy season. So yeah, it was
Yeah,
a
and
big deal.
what does that matter anything at all? Like,
Oh, it
why?
does because when you're doing sub-arc second precision in 1919, taking photographs on glass plates, it matters so that
It matters what?
because if you don't control for confounding variables, then you can get garbage data.
Because it could be raining, and it would be a shame if it was raining.
Yeah, you
Well,
also you
then
couldn't even
don't do
if
it
it's
while it
raining.
is raining.
Yeah, but the
Then
problem
don't
is
do it while it is raining. That's it. You don't have to tell me anything. Just don't do it while it is raining,
well,
and don't even tell me about
yeah,
your life
definitely.
problems. I don't care if your wife broke with you. You don't have to tell me about it.
Yeah,
You know?
super. Those kinds of
Yeah, I
complaints
don't care.
don't actually aren't meaningful because the actual data. You could have skipped ahead to the actual data if you wanted.
Yeah, that's the thing. I can't skip ahead. I actually asked
No,
the
you have
Discord server, the
permission.
guys, if
You
they
have
could
permission to
point
skip
me to
ahead.
the important thing because I
You
was
can
reading about
you
raining
can skip
seasons,
ahead.
and
You
they
really
didn't
can.
want to point me to it. Probably because there wasn't even anything.
Probably because there wasn't even anything. Are you serial?
Yes, because I read a lot, and I say, as I told you most times, there isn't even anything.
All right. Well, let's have a look, shall we? Eddington, 1919. Should we look at it quick? Here's his paper. 44 pages. Yeah, it's a good sized paper. A determination of the deflection of light by the sun's gravitational field from observations made in
There's
the
the
total
raining
eclipse of
seasons.
May
Make sure
29,
we are all
1919. Right? So he's got purpose, preparations, the expedition to Sobral, the expedition to Principe, and then general conclusions. You know, we could just jump forward to the general
just show me
conclusions.
the maths. Show me where it uses Newtonian physics to actually calculate with numbers the prediction with Einstein's supposed formula, because I've never seen any formula or any way to actually use general relativity and how it uses it and calculates it, and what was the observation.
All right. So
And the difference, because all three things.
The purpose of this paper was not to run through Einstein's prediction. Einstein output his prediction of
Then
what?
It didn't even calculate the supposed prediction of Einstein.
Einstein predicted Einstein's prediction. This paper didn't predict Einstein's prediction. That's not its purpose. Its purpose is to measure the deflection and compare
Are
to the
you
previous...
kidding me? It literally doesn't even contain the Einstein prediction.
No, it does not. It doesn't have to. That's not its purpose.
Then, as I said, there you go. It's worthless. There you go. Worthless.
You can literally find that elsewhere if you want to go through that and make sure that Einstein got his math correct.
Exactly. It doesn't provide the math. You have to search for the math.
It doesn't need to.
But
I
tried to search for how for how general relativity supposedly does predictions, and I've never found it. Probably because it doesn't exist.
That's a PEBCAC is what that is.
What?
That's a PEBCAC. The fact that you weren't able to find it is what we call a PEBCAC.
Just I don't know if it's very relevant to you or anyone in the chat or whatever, but technically I also used ChatGPT and tried to have him explain to me how relativity supposedly works and how general relativity supposedly works. He contradicted himself like 3 or 4 times, and he couldn't agree on anything. He literally didn't know what he was saying.
Copycat, I think you're right. I don't know.
Like, it's just ChatGPT, and I know he has other problems, but just another plus.
All right, so here you go. Radial displacement. Distance. Look at that. Yeah. I mean, you could have just jumped ahead and seen it right there. Look at that. There it is.
I told you, it's worthless. It's worthless. You told me that it doesn't contain the Einstein prediction. So it's worthless.
Yeah, that wasn't its purpose. Its purpose was to measure and then compare to the previously done work.
To the Newtonian, I guess the Newtonian prediction. I guess it calculated the Newtonian prediction and did the observation. I guess. I have to guess.
Them, so there you go.
But that's worthless. And what it had it was a little different.
Do you want me to do the research for you to find Einstein's work predicting the...
I mean, it's the claim. You have the positive claim that, well, you and many people claim that it like matched with Einstein and it proves that relativity.
Nero,
well, that's a you claim that you have the burden of proof.
But it's not my actual... When I'm talking to a flat earther, yeah, I'll hand them the stuff and shove it in their face. But you're not a flat earther. You're not coming at this, from an ignorant moron perspective. You're trying to come at this from an intelligent person's perspective. It's on you to actually do the background work, not everybody else to hand it to you when you're just sitting there and doing nothing. So if you could not find Einstein's...
It literally does not contain anything. What are you talking about? Even if I researched it and I found this is worthless. And I did a lot of research in 3 years. And I didn't find anything because it doesn't exist.
Because it doesn't exist. All right, let's...
Yeah, it doesn't exist. Proof. that proves it. As you just said, this paper is worthless because it doesn't even
this
contain
paper's
Einstein's prediction.
purpose was not to run through Einstein's
Yeah,
field
I
equations and
know,
output
and
the
that's
prediction.
why it's worthless.
That was already done before this expedition was thought of. Right? That wasn't its purpose. So if it had already been done, why would they go through it again? It's already been done.
What?
Right? So you don't when you're testing somebody's prediction, you don't need to redo all of the work that they did in their prediction. You simply reference it. You say, as predicted by blah, and that's your link to,
Right,
to
yeah.
the person. And so then the reader's like, okay, well, let me go look at that stuff so that I can get up to date on that if I want to. Or if I don't want to, I'll just not. Either way, you have the opportunity to do that. But it's not on Eddington's burden to include all of the work that Einstein did in his previously published work. Eddington just references it and says, go look it up yourself. That's what you do.
All
So
right,
this-
that would be fine. If
So
the
this is a
Einstein,
hypothesis testing
if
expedition.
it contained this exact scenario, or like, I don't know, maybe if it explains the maths good enough so you can kind of do it, but I've never seen even how you supposedly calculate general relativity. I've never seen it once.
You've never seen it calculated. All right, well, I'll tell you what. We'll go
No,
look at it.
and I don't
sometime.
think that
All right, so here
Einstein
is-
had it for this
just-
specific
just for reference. All right, the
scenario.
dashed
probably.
line is Newton prediction, because Newtonian
Which one?
physics predicts a deflection half as much as
Which
the
one?
Einsteinian one. And the dashed line
The
is
one
Newton's.
on the bottom.
Yep. The thick line is Einstein's prediction there.
Einstein's prediction.
Yep.
So he did. He just didn't talk about it in the paper.
Yeah, he did. Here, I'll read it to you word for word. Here we go. The
He
displacement
did the
according
maths.
to
He
hold on, just a minute.
calculated Einstein's,
The displacement,
but he didn't put it in the paper
according
or what?
According to Einstein's theory indicated by the heavy line, according to the Newtonian law by the dotted line, and from these observations by the thin line. So the thin line is the
Right.
averaging.
It says according
Yeah.
to Einstein's
Yeah.
theory.
Yeah.
But
So that
according
is
to Einstein's theory, that I did myself, the calculations that Einstein did, that
No.
someone else did.
no. Not what's not
No
not
one
necessarily
did.
what
But we
Eddington
know
did.
that it
No.
is that one.
Yeah. So then
No one did,
the
but we know
astute
the
reader
value.
would go and find what Einstein wrote. So Einstein wrote several
if-
multiple papers. I'll tell you. Here we go.
But you understand that
Here we go.
someone
Hold on.
had to do the calculation to know
right,
the,
so
the
I don't
predicted
know-
value.
I don't know offhand where Einstein published his predictions on displacement. But
Someone
here-
on the chat says that Einstein did. Einstein did for that specific scenario.
no,
The exact
in
observation that he
general,
did.
Yeah, the
I'm asking
specific
the
prediction.
the guy
The
on chat.
specific prediction is a certain magnitude of deflection at the sun's limb. Okay.
Yeah.
I think 1.75 arc seconds. That's it, right? So then all of the other ones that are when you look at that, you say, well, how far is it from the center of the radius of the sun? And how far is it then from the limb of the sun? And so what's Einstein's prediction for that particular distance from the center of the sun? Because it varies based on the distance from the center. So Einstein didn't need to calculate the precise amount for any of those particular stars that Eddington looked at. He output a formula, basically, 1.75 arc seconds at the limb of the sun. And then it's related to the distance inverse square as it moves farther out.
And what was the prediction of Einstein? Like, what was the rate?
1.75 arc seconds at the sun's limb. So here is Einstein papers.press.princeton.edu has a collection of maybe all at least a large portion of Einstein's papers, translated into English. Being an American, I don't speak German, don't read German, I only read American. So
Neither do I.
I'm limited to reading it in English. And I don't know about your German, but if you're a Spanish speaker, you might prefer something in Spanish. But I don't know if Einstein's been translated into Spanish.
I don't know.
So anyway, on my website, mc2.net/relativity, I've got his 4 big papers from 1915. The third one is the perihelion motion of Mercury from the general theory. See, but it doesn't specifically reference Einstein's light bending prediction. So in these 4, now this was in 1915.
The perihelion motion.
This was published in 1915. But he was back in 1911. He was talking to people, asking them to go measure light deflection, and he had initially in his calculations done it differently than he came up with the end. He had made some mistakes, and he wasn't all the way through his general relativity work initially. And his initial predictions when he was asking astronomers to go and measure the light deflection was half. It was actually the Newtonian quantity. So if they had had success in measuring the deflection and measured the actual double of what he at the time was predicting, who knows what would have been different? That's an interesting idea, because it might have completely deflated him, and people might have said, oh, well, you were wrong, we don't know why. And then he's going to come back later and say, oh, but it's this one, this larger one. I do predict what we see now. And people might have said, ooh, an interesting fix there, buddy.
What's the prediction of Einstein? I mean, of Newtonian.
Newtonian is half.
Half.
Yes.
About half.
Half of what Einstein. So 0.9 or 0.875 is the deflection at the limb of the sun. Arc seconds. All this is arc seconds. So 0.9 arc seconds deflection at the limb of the sun is the Newtonian prediction. 1.75 is the prediction of Einstein at the limb of the sun.
Right, but then we will need to know exactly how general relativity works, because I was never able to do it.
Okay, well, it's on screen right there. So these would be the places for you to start if you wanted to go through it right there. mc2.net/relativity. It's right there for you. It's been there for months and months. So probably a couple years since I put it up here. So what do you think? Yeah, you can go through it. And then and if you want, I'm sure people probably right now could find for you Einstein's paper on the light deflection,
I tried many times. Even on the Discord server, supposedly one guy was trying to explain to me how general relativity worked. I think he even sent me a video on YouTube. He did, or someone he knew did, or something.
Okay.
And it didn't make sense. There were many problems. We couldn't even go through the entire video because I had so many doubts, and he wasn't able to answer them.
Okay, so we've got right here. Philip Kidd says in explanation, which is right here, this third one, page 116, top of right-hand column. Let's have a look. Page 116, there's the right-hand column. Let's see what we have here. We've got C denotes the velocity of light in units. Calculation yields for the planet Mercury. Oh yeah, this is the perihelion. So what about the light deflection is what we're looking at.
I actually don't really care.
Oh, you don't care anymore?
Neither of them convinced me because of what I saw. In this specific case, like you said, that Newtonian apparently predicted half.
Yeah.
And Einstein once was more or less on point. But the Mercury's perihelion, I searched a lot. Again, I researched a lot, and it was very hard to find even one. And the one I found, it was like Newtonian was 99%, and Einstein was 99.2%,
So let's you couldn't find this one
which
right here.
doesn't sound convincing.
You could not find this. It's been sitting on my website waiting for you to find it. You said you looked on my website. It's right here on my website.
I didn't look too much on your website,
And you didn't just Google like general relativity.
and I'm honestly not finding a lot of
perihelion
stuff.
Mercury. You probably might have found it that way. Okay, we've got. This is a good one. So we've got from Clive Wells, page 45 for the prediction. So let's see here.
All right, here. I know.
You see that one from Clive Wells? There's a Newtonian limit there. This is again Mercury's perihelion, which is different than the light deflection.
Well, technically, they both use general relativity.
They certainly
supposedly.
do. Yeah. So, all right. Well, I mean, on my website's been Einstein's paper, and then this one is somebody else's paper. Going through the same thing to get the perihelion of Mercury and other things.
Well, yeah, I remember some of the confusions that were like when we were trying to like. I was asking him how general relativity supposedly work. Like he talked about using 4 variables with I don't know if like position or speed, and I thought it was like transitional, like as in transitional speed or whatever, and then he said that it was rotation, and I wasn't sure how rotation even like was like he wasn't able to define like what the the letters, the variable in the formula were. He was changing because I said, why does it use Greek letters? Because it uses Greek letters, and he says that's because it's because it's of rotation. But wasn't that of translation?
I don't know what you're talking about.
It's like
so
I don't know
I can't.
of the supposedly if not fully, at least a part of Einstein's
it made no
general
sense.
relativity equation.
Do you not like Greek letters? Did they do something to you?
They were weird, so I asked him why they were and what they meant.
You asked who?
And
who did you ask?
What?
Who is it that you're talking about?
Someone on your Discord server.
Someone on my okay.
I said that I never seen the general relativity equation and calculations and trying to that. And he said that all right, I can explain them to you myself. And I have a video. I think the video was him, and she sent me the video too. And I was with him commentating the video and the explanation. He was talking to me in theory, trying to explain it, and those things arise. Like in the equation, there were those variables with some Greek letters and some regular Latin letters.
Right.
And I asked him what they were.
Brenda says, surely even a software engineer would be familiar with Greek letters. We don't use Greek letters in software engineering.
Yeah, no, we don't.
Everything is just Latin letters.
Well, technically, we use like alpha and beta and stuff.
Like we type them out.
But yeah. But like.
But that'd be that would be a bad variable name. First of all, you need to prefix the variable name with the type of data you're putting into it, right? So if it's alpha, then it might be, or say theta. that'd probably be an angle. So you're definitely going to prefix it with an F. But then theta, that's not enough. It's not descriptive enough. You need to have
F
more of a
as in
name.
float?
F as in float. Yeah, so it's going to be F, theta,
In
or
what
F,
language?
the angle that I'm trying to measure. That'd be a better one. All, of course, in camel case.
But in what language you define a float with just an F?
Java, of course.
Java.
Yeah.
Java? Seriously?
Yeah.
I programmed it in Java, and
What's wrong with
but I
Java?
never used floats, so maybe.
Oh, I use floats. Yeah. I use I don't know what. So if it's a primitive type and I count strings as primitives in Java, it's a little bending the rules, but they just get a single lowercase letter. And if it's a
Oh, no,
an
wait.
object,
But
it
you
gets
mean
more than one letter.
you mean the F next to the number?
No. If it's a variable name, right? So F, lowercase f, and then camel case, the angle I'm trying to measure.
For the name of the variable. You put an F on the name of the variable
Yeah, at the beginning.
to
Yeah.
indicate that it's a float.
Yes. So
Yeah,
then when the next person comes along, who might be me, I know what that variable contains. So I know already what I can and cannot do when I rock that variable.
Well, yeah, I guess, yeah.
Yeah. Yeah, Hungarian notation is what we call it. And then camel case is the camel case is, right?
Yeah.
Yeah, okay.
But I never remember which one is which, Camel and Pascal.
Camel and what?
And Pascal was, I think, right? The other one.
Pascal.
Pascal notation.
I don't know.
Wasn't it called like that?
And
I never say the names,
and
that's why I
of
confuse
course,
which one is which.
always almond style curly brackets, not Kerning and Ritchie, please.
I just usually do whatever. Like, I just program for myself.
You just program that program for myself. Coming back 3 years later, it's always nice to jump into some code that you've not seen in a while and you've completely forgotten everything about it, and you get into it and you're like, hey, whoever wrote this was really nice to me. It's all well documented by descriptive variable names and function names. Oh, that was me.
No,
what a nice guy I was to me.
Yeah, no, when I go back to my code, first it's alien. I don't understand anything.
Oh, gross.
And then after some time, I understand everything again.
Do you write in Perl? That's the worst.
I mostly write in C#. But I
just threw it in my mouth,
which is very similar.
All right, well, I'm going to read some super chats. People I think are trying to I don't see anybody that has found yet a Einstein's 1.75 arc second prediction at the limb of the sun. But if nobody does, then I'll look for it after the fact here. String News 1 says every Tuesday is Thanksgiving at Lake Titicaca. And it is a Thanksgiving this week on Thursday. What are you doing for Thanksgiving, everybody, including you, Nero?
I don't celebrate Thanksgiving. I'm pretty sure.
That's rude. What kind of a Scrooge are you that you don't celebrate Thanksgiving? Dave Kircher says, thanks to Titicaca, it's Tuesday, and thanks to Superman for keeping us attached to this spinning globe. Caucasian Sensation says, his brain is relatively small. Does he understand? Mr. E-Man gifted 5 memberships. Thank you for that. Randomly Epic has a member super chat. Or no, is a new member at Einstein. Awesome. Thank you for that. Indie Tiger Sci-Fi Review says, I'm not a fan of Maxwell Light. Maxwell Dark Roast is better. I read that earlier. And then Stringer News 1 says, I prefer Maxwell Smart. I do. I will go with Maxwell Smart over. Now, do you prefer the old one or the new movie? The new movie was good. Sometimes, they ruin it. But I do like the new one did a good job with Steve Carell. Did you like that one with Steve Carell, Nero?
I don't know what.
Yeah, okay.
Right.
Super. Tim Tully says dark roast has less caffeine. All the more reason to have light roast. Fa of the QTube family says, I joined 23 minutes in. Did I miss any derp? A bit. Industrial Nerd said, this is for you, Nero. Industrial Nerd says, Nero, then why do analog European records play a 16.66% faster in America? All hail dark roast.
What?
Yeah, you didn't know that?
What?
That's due to relativity.
The what?
Yeah.
But the what?
European record players play 16.66% faster in America due to relativity.
Record players.
Record players.
Record players, as in,
Yeah, do you know what a
What?
record player is?
I'm not even sure.
How,
Like, is that an old thing? Like the
how
thing
old are
that
you? How old are you?
I'm somewhat young.
Okay. Have you ever seen
So maybe it's like,
you ever seen a DJ? Like Will Smith's got a DJ. I'm the DJ. He's the rapper. That song, where they have the record and they're scratching. They're like that
Yeah.
thing. That's a record player,
yeah.
and the record is spinning. It's a vinyl. It's a plastic type of material. Plastic, right? And then
Yeah.
and then it spins, and there's actually music embedded in the groove of the plastic. That's a record player.
Yeah, but that what does that have to do with relativity? I don't understand.
Yeah, so in America, if you have a European record player, when you bring it to America, it spins 16.66% faster. So the records actually play a little bit faster. The pitch is a little higher.
What? That makes no sense. It's like a joke.
It sounds like a joke because it's a little chipmunky, but
No, but
relativity,
like you're
you can't-
literally saying that
you can't
it
argue with the
spins
laws of physics.
faster or slower a CD. Like what? It sounds like a joke.
So somebody wanted to clip me scratching. Yeah, good luck. Good. Fa of the QTube family says Pink also sang Funhouse, which was the anthem for my old apartment. Yep. Streamers one says one way is a velocity, not a speed. Do you know that? The one-way velocity. Yeah, because velocity has a direction.
There's no difference. I'm pretty sure there's no difference in definitions from speed and velocity.
Oh, there's a difference. Yes, velocity is a vector, and speed is just a magnitude, no direction.
Oh.
Yeah.
All right.
Yeah. So, like, for example, the band that used to have Harry Styles is a vector. It's a unit vector, in fact. You know that? The group that used to have Harry Styles?
No, I don't know.
Never mind. Some people think that I'm Harry Styles. They're like, you don't even look like Harry Styles. I'm like, exactly. Why do they think that?
It's almost the same, like speed and velocity.
Nero fiddles while Iceland burns. That's when you said Iceland. Well, when you said Iceland instead of island. In English.
Yeah, that's because
because you're Spanish and
in Spanish
I get it. Yep. Eddie Reese says this guy understands just enough to still not know he doesn't understand anything. I think he's got a little more than that, Eddie. Chris says Stefan J.G. Gift, professor of electrical engineering, Google Scholar. That was the guy that published those two papers. The guy from Trinidad and Tobago, I think. Right? Janusz Takas says, dang, I sent this to the other chat. My favorite Pink song is So What? From the lyrics, Na 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 na. That's a good song. Very catchy lyrics. Those. I like that song. It's a good one. Toads in My Eyes says people have done more and other experiments that explain more about these phenomena, and they still all follow the predictions. Yeah, and those papers also don't include the workup typically of the full workup of the prediction. They just reference that. So, Randy Leahy. Are you familiar with Randy Leahy from Trailer Park
No.
Boys? You should watch that.
What?
Says Einstein's theory of relativity is for measuring the mass of hamsters. Nero,
Yeah.
2023. There you
No,
go.
but I think I didn't say quite that. It was a little different, but yeah, there was a funny quote either way.
I think I'm just leveraging leveraging the difference between your language, your native language, and the language we're speaking right now. So, thank you for that. Virillion says, was the plain color yellow or red? That must affect it too, right? Yeah, where it was doing circles doesn't necessarily mean a whole lot. But if you study the philosophy of science, when somebody says when somebody tries to get to the point where they're like, I proved something, you say, well, yeah, but how did you know that the color of the guy's shirt didn't change something? Well, of course it didn't change anything. Well, how did you prove that it didn't change anything? Oh, well, you could only inductively figure out that the color of the guy's shirt would not change something. You can't prove it until you've established that it's true, until you actually do an experiment to test. Vary the color of the shirts. That's your independent variable in the next iteration of the experiment to make sure that shirt color isn't doing it. And then you can look at the number of chairs in the room, and then you can see whether or not there's pigeon poo on the roof. There's another variable that you didn't prove. Right?
Yeah.
Yes. All right.
The more you
Caucasian.
test, the better.
What's that?
The more tests you do, and more variables, it becomes better and better and more reliable.
Yes, but sometimes there's things that you just don't care to test, like the color of a guy's shirt. It's not likely, so it's not something you typically test.
It's not really you don't care. It's you have many things to test. So first you test the things that you are like. That's what hypotheses are for. You test the things that you think are more likely. That's like literally the why hypothesis exists. You do a educated guess. So it's something that you think it's more likely to be. So you test that first. You test the things that you think are most likely, and the testing the amount of chairs probably is very
but you can only really get to those things through induction, which isn't it's useful in figuring out which hypothesis you want to look at next, but you can't rely on induction for conclusions. All right, here we go. We've got the foundation of general relativity. So this is from No Genius here. So I'm looking at this blind, but he says that he or she says that this might be the deflection of light derivation. There it is. According to this, a ray of light going past the sun undergoes a deflection of 1.7 seconds, and a ray going past the planet Jupiter, a deflection of about 0.02 arc seconds. There you go. I will send that to you. I've not done a whole lot of vetting on it, but there it is. Thank you for that. Darryl Frost says you construct an error budget where you identify possible causes of error and you take measures to reduce those and understand them. Yes, very much. And how do you quantify the error budget for the color of a guy's shirt, whether it's chartreuse or salmon? You can only inductively do it in many cases, but maybe something is hypersensitive to photons. Then it might matter. We can only inductively figure that out sometimes. Anyway, all right. We've got Caucasian Sensation says this dude is exhausting to listen to. So, well, all right.
Yeah, why?
Well,
I'm not that bad, am I?
He's got his reasons. Well, you kind of hand-wave dismissed Eddington because you didn't like reading about weather, but weather is a confounding variable in those types of measurements.
It's not relevant talking about if it's a raining season, and I've read so many worthless stuff. I also have a life.
It's very relevant.
I can't be reading about raining seasons.
But Nero, it's very relevant when you're selecting the location for your observation. You don't get to redo it.
It doesn't matter. I don't care.
Then skip it.
But no one even wanted to give me like where I should go, or even in the paper there was anything about where I should.
Nero, you're not a flat earther. Nobody needs to hold your hand to go find things. Nobody held my hand when I read through Eddington.
It's a very big paper, and most of the stuff I read is worthless.
Yeah, I skipped over most of it. I did listen to. I didn't read. I listened to 2 books, No Shadow of a Doubt, and another one on the eclipse measurements. Both of them fantastic books. Boy, wouldn't it be good if I could remember the name of the other one? Geez, I'm gonna have to go to my Audible. Wait, I have them in my. Hold on. I will give you the names of the 2. I'll give you the names of the 2 books.
But instead, I read way more than 100 pages of stuff.
Oh, that's so many.
3 years.
How did you handle it? No Shadow of a Doubt and Proving Einstein Right. Those 2 books. No Shadow of a Doubt I liked better. It was by Daniel Kennefic. I'm going to try to contact him and get him on. And then
but honestly, it's very hard to convince me because I like the Michelson Morley experiment is like an extreme evidence to me.
Okay.
Like if it's all based on an assumption, then I don't really care much if those supposed predictions are very right.
Every hypothesis can be a guess or an assumption or a whatever. It doesn't matter, right? You can come about your hypothesis anyway that you want.
You literally make up an assumption, and then you make up a way of predicting things like a model, and that happens to somewhat correlate to the observation, which you can like manipulate in any way you want to get the results you want, and you get any prediction and it matches reality, and you can claim anything and have like any assumption. I don't think that's
if your prediction matches reality, then super. But do it again and again and again and again, and if it continues,
and it probably does. I don't care.
It doesn't matter how you got it. It could have been just a wild guess. So, all right. MK Ultra says he lost interest because of the season. I haven't listened to a word he said because of the accent. Only fair. I guess so. Martin Smith is a new member at Newton. Jerry Graybosh says, sounds like he wants to bypass a physics degree and go right to doing peer review. Yeah, you should write this up. Write up all your stuff. But don't talk about the weather. Definitely don't talk about weather.
No, I don't talk about weather. Yeah, I don't think it's relevant to anyone. Or if I have a wife, or if she breaks up with me.
Well, I hope she doesn't break up with you. Just don't tell her that you didn't read Eddington because of the weather. She might not find that compelling. Comrade J says, whoa, no one told me there'd be reading. And Paul Anthony says the crested hamster isn't actually a hamster, but a rat. And it's Paul Anthony's first super chat.
Gibus, I said more than 100 pages, not exactly 100 pages. You think I count the exact amount of pages I read?
I don't know.
I don't know how many.
I've read thousands.
Dude, literally, like everything you say, no matter what you say, they will find a way to try to make fun of you.
I know. It's a tough crowd.
Yeah.
Oh,
Yeah,
you know what?
Yeah, so 102,
this.
exactly, 102. That's the
I'll
correct
show you
amount.
this,
102.
people. I'll show you this
Exactly
in
102.
the next stream, unless the guy shows up, which I'm kind of guessing he isn't. But I mean, look at this. Look at this. I read this. I read this. I haven't read this yet. I'm working. I'll probably read that. I've read this. About half of this. Chapters 3 and 4 are the best of Popper here. I got this one is super good, super good. Inventing the flat
Thanks,
Earth,
PG,
Columbus,
PGCnet.
and modern historians.
Another nice comment.
PJCnet. Nero says Nero did well, especially when English is a second language. He should question even more. Yep. Let's see. So I've read. Oh wait, hold on. Here you go. Oh, I read this whole thing here. This one here. This one here. Kuhn, Structure of Scientific Revolution. That's a good one.
Mr.
I mean, I listened to the audiobook of it. So some I read, some I do audiobook.
Is Industrial Nerd asking me if I ever seen the rain?
If you've ever seen the rain in Spain, where does it mainly fall?
Rain.
Yeah, where
Everywhere,
does it mainly?
I think.
Where does it mainly fall? In Spain.
Everywhere, I think.
Does it mainly fall in the plains? Might you say? Let me just. Could we agree that the rain in Spain falls mainly in the plain? What do you think? Can we agree?
I don't know. I honestly don't know about weather.
Yeah. Screw weather. Damn it all to hell. Cretan Ball says, I bought a Honda Civic. The owner's manual didn't tell me how it differed from a Ford Model T. I can only conclude that my Honda Civic is a hoax. Eddie retracts his previous super chat.
They are again still on the pages, dude. The amount of pages. They literally care for how many I've read.
I don't know. All I know is
I don't know.
I'm still just wondering if we can agree on at least where the rain mainly falls in Spain. But I don't.
I don't know. So
all right. Fa of the Q2 family says, Nero, it's because of the AC synchronous motors and record players. The US uses 60 hertz AC, Europe uses 50 hertz AC, which affects the motor's speed.
Oh, then it's not about relativity.
Well,
and it doesn't have anything to do.
There is a relativity relationship between 50 hertz and 60 hertz. They're relative.
Dude, it was a joke all along. I called it.
Wizard of Oops says, I'd like to donate this to Nero's recovery from reading like 100 pages.
Again, I already said the amount of pages. 102 pages, exactly.
102? How did you survive?
Yeah, exactly.
Oh my gosh.
I counted it one by one. Exactly 102.
You expect him to have seen My Fair Lady? No, I do not expect him to have seen My Fair Lady. Oh my gosh. All right. I've got a Facebook flurf coming up in just over 5 minutes, and I need to cut a whiz. So, Nero, I don't know if anybody was convinced by your position, but I thank you for.
I don't think anyone was.
Thank you for joining. I do appreciate that that you're not a flurf. So that's a anyway. Anything to say as we head out?
I wasn't like I didn't like how most people treated me. Like I believe even flat earthers shouldn't get this kind of like even if you disagree with someone, you don't have reasons to be rude or to insult. Like like you can maybe say something like that's stupid or maybe you're thinking that's a little stupid or something like that, but like there's a point that like they were like bullying me in how many pages I read, just trying to get something. Like even if it's a flat earther or if it's very dumb or anything, try to be polite with people. And I didn't like that a lot. Only a very few, like 2 or 3, the guys were somewhat polite.
Right. Well, it's a tough crowd, isn't it?
And I appreciate the ones that were.
Yeah. All right. Well, Nero, thanks for joining, and we'll see you. We'll see you later. Here we go.
MC2, drop that beat.
All right. Let it flow. Let yourself go. So I know that is the tempo.
So, yeah, let's do this. So,
Let's do this. Yo, it's MC2, the debunking tycoon. I shatter flat earthers, make them face the moon. Your attempts are decent, but they'll swoon in the face of my logic like a deflated balloon.
Oh, MC2, the one soon cartoons. Unreal say send it first to their dues. Your theories are like old brooms, sweeping ignorance or just spreading the views.
FDFE stands for fumbling the facts, evidently. I drop truth bombs so splendidly. Your approach is soft, mine's unrelenting. I bring the science while you're just venting.
MC2, the buffoon with silver spoons. I tackle pseudoscience to make them change their tune. You're the sidekick, I'm the room. When it comes to debunking, I'm the room.
In the rizzle dizzle. But hey, FTFE, we share the creed to educate and debunk the plant the seed. Though in this rap, it's clear indeed I've got the upper hand than word indeed. Alright, hold on a second. The Zoom call died. Everything died! No!